Look up tonight and imagine if there were two moons glowing together in our night sky. We are used to having just one moon, which controls ocean tides and gently lights our nights. But what if Earth suddenly had two moons orbiting our planet at the exact same time? Using physics computer simulations, planetary scientists modeled exactly what would happen to Earth. The definitive answer from researchers: absolutely everything on our living world would change completely, from the churning ocean tides to the night sky and life itself across all global ecosystems. Let us dive deep into the fascinating science to find out how this unfolds.
Ocean tides go crazy when two massive celestial bodies exert gravitational force on surface water.
Currently, one moon creates a regular, predictable cycle of high tide and low tide daily. Two moons would continuously pull Earth's oceans in two completely different spatial directions. Sometimes both moons line up perfectly in alignment, creating a combined gravitational pull.
That rare event is called a supertide, generating massive tidal surges globally. Ocean waves would rise 2 to 3 times higher than anything seen in modern history.
Coastal cities and shoreline ecosystems around the world would experience frequent cataclysmic floods. But at other times, their gravitational forces cancel each other out completely nearby. During those cancellation phases, the ocean surface goes remarkably flat and eerily calm.
Marine life dwelling near coastal beaches would be forced to adapt remarkably fast to survive.
The night sky would undergo a dramatic transformation under two glowing natural satellites. Having two moons in orbit means receiving twice as much reflected sunlight overall. Nighttime on Earth would become approximately 30% brighter than it is currently. True pitch-black nights would effectively disappear from most populated parts of our planet. Nocturnal animals that hunt under darkness would be forced to adapt their instincts rapidly. Predators and prey alike would experience altered hunting strategies and radically shifted behaviors. Furthermore, celestial eclipses would occur with incredible frequency across all seasons every year. Imagine watching one moon pass directly in front of another across the night sky.
Spectacular double lunar eclipses would paint the nighttime sky in deep crimson tones.
Stargazing from Earth would become an ever-changing cosmic spectacle of motion and light.
Gravity and orbital mechanics create complex interaction dynamics between two massive moons.
Two moons orbiting Earth would pull not just on oceans, but on each other. Over extended periods, their orbital pathways around our planet would become highly unstable. One moon might gradually get pushed farther away into outer deep space. Meanwhile, the second moon could get pulled significantly closer toward Earth's surface. Over millions of years, a closer moon could eventually crash directly into Earth. Alternatively, both natural satellites could settle into a complex, harmonized gravitational dance.
In physics, calculating three interacting gravitational bodies is known as a three-body problem.
Three-body orbital systems are notoriously unpredictable, chaotic, and inherently messy to calculate.
Mathematical simulations reveal unpredictable orbital shifts over vast geological timescales across eons.
Timekeeping calendar systems and human culture would evolve in entirely new directions. A single moon gives us our traditional monthly calendar cycle of 29 days. Two moons with distinct orbital periods would create two conflicting monthly cycles. Imagine trying to synchronize daily life using two completely different lunar calendars simultaneously. Ancient agricultural farmers, ocean sailors, and tribal elders would track both moons closely.
Seasonal harvesting routines and maritime navigation methods would become significantly more intricate.
Cultural holidays, religious festivals, and ancient mythologies would feature twin lunar deities. Human folklore and artistic expressions would depict twin celestial bodies across all cultures. Our historical understanding of time measurement itself would look fundamentally different today.
Biological life on Earth relies heavily on precise gravitational and moonlight cycles.
Ocean tides guide the reproduction schedules of coastal crabs, reef fish, and corals. With two distinct lunar forces, those natural reproductive cycles would become chaotic. Specialized marine species that adapt quickly would thrive in this dynamic new environment. Three-body orbital systems are notoriously unpredictable, chaotic, and inherently messy to calculate. Nocturnal flora and plants using ambient moonlight would alter their photosensitive growth patterns. Human circadian rhythms and sleep patterns would also experience noticeable biological adjustments. Human biology and hormonal fluctuations correlate with natural lunar illumination more than expected. Restful sleep cycles would shift, alongside altered nighttime lighting and atmospheric tide changes.
Could Earth actually acquire a second moon in the foreseeable cosmic future?
Yes, multi-moon planetary systems are actually quite common throughout our solar system. Small rocky Mars possesses 2 tiny moons, while giant Jupiter hosts over 80 moons.
For planet Earth, a second moon could arrive as a captured near-Earth asteroid.
Alternatively, orbital debris from an ancient cosmic impact could gradually clump together again. While capturing a large, stable moon is rare, fundamental physics proves it is possible.
The vast universe surrounding us frequently creates balanced pairs of orbiting celestial bodies.
Astronomers continuously monitor surrounding space objects that could potentially become temporary mini-moons.
Having 2 moons presents both extraordinary advantages and formidable environmental challenges.
On the positive side, brighter nights offer breathtaking views and rich scientific discoveries. Astronomers and space explorers would possess 2 distinct celestial stepping stones into space.
On the challenging side, extreme tidal surges would constantly threaten coastal infrastructure.
Unstable long-term orbits present cosmic hazards that humanity would need to navigate carefully. Managing complex twin calendars would complicate agricultural planning and international timekeeping systems. A twin-moon Earth would undeniably be a visually stunning world to behold.
Yet maintaining human civilization on such a dynamic planet would be vastly harder. Delicate orbital balance is ultimately everything in the vast mechanics of outer space.
So what happens if Earth had 2 moons? Bigger tides, brighter nights, messier orbits, and a whole new way to see the sky every single night. We only have 1 moon, And that one is perfect for us. If Earth got a second moon tomorrow, what would you do first? Comment below. Subscribe to get new science exploration videos every single day.
And remember, even one moon is enough to change the world.
Understanding planetary physics helps us appreciate the delicate equilibrium that sustains life on Earth. Our ocean currents, seasons, and daily rhythms are finely tuned by our solitary natural companion. Our single moon stabilizes Earth's axial tilt, keeping our global climate predictable for millennia. Without that gravitational stability, Earth could experience extreme climatic shifts across continents. Every night, our sky delivers a subtle reminder of the perfect balance in space.
Space exploration reveals how unique our solar system truly is among distant star systems.
Distant exoplanets often host complex multi-moon systems that challenge our understanding of physics.
Future space missions will study moons around other planets to unlock planetary origins.
The simple sight of our moon inspires wonder, science, and curiosity across human generations. Scientific models continue to refine our knowledge of gravity, orbits, and cosmic evolution. Navigators throughout history relied on regular celestial cycles to explore uncharted oceans safely. Stable coastal environments fostered rich biodiversity that shaped the course of evolutionary history.
Human civilization thrived under predictable patterns of sunlight, moonlight, and seasonal weather shifts.
While twin moons create fascinating scientific scenarios, our single moon provides life-giving balance. Humanity's next step involves returning to our single moon to build permanent scientific outposts. Exploring our own moon prepares us for journeying deeper into the cosmos beyond. Every discovery reminds us how interconnected our planet is with the surrounding universe. Science invites us to dream, question, and marvel at the endless possibilities space holds. Thank you for exploring the wonders of science with us today. Stay curious. See you next time on our journey through the cosmos.